You can move that over on the
I'd
table.
like to move the strap a little bit. I don't know if I'll use it or not.
Okay.
Okay. You're fine. I'm happy to be here this morning, and I'm excited about this. I'm nervous, like Tim was, about being able to cram everything into 15 minutes. The topic for today is about designing the different 3D guitar features for the neck and for the body. I've got somewhere in the neighborhood about 45 slides, so I can't spend a whole lot of time on each one of the slides.
Hang on a second.
Yes, sir. What are you doing?
I'm going to restart you just to make sure I've got it recorded.
Okay.
Okay,
We'll restart the clock.
we'll restart your clock.
Just shut it off.
Yeah, unfortunately.
Now you don't have to talk about the 15 minutes and 45 seconds.
Well, that saves 20 seconds.
That's the applied math.
Yeah.
There you go, you're rocking now.
Okay.
Starting to call now.
Okay. My setup for doing CNC work and design work is I've got a ShopBot CNC that's 24 by 32 bed, and I've also more recently acquired a 48 by 96 bed machine. But I do most of the prototyping and the trial and error experimentation stuff still on the smaller machine. The software that I've got is Partworks that came bundled and licensed with the ShopBot machine. And in an educational setting, you can install that software on as many machines as you want to in the school building for student use. And while I have used Autodesk Inventor for this type of work, most of the stuff that I do is with a PTC product called Pro Desktop. Anybody know of PTC Pro Desktop? One guy, awesome. So there are no licensing fees. I own it outright. There's no renewal of subscription or anything like that. And it runs on anything from Windows 98 up to Windows 10. Two ways to go about making a guitar body. Sometimes students will get a guitar body JPEG off the internet, and I will show them how to scale it. There's a little math application off of the current image size, how to scale that up so that the neck with the measuring tool works out to 25.5 inches from the nut to the bridge saddle for the small E string. Or design a body from scratch and drop vectors onto it for the neck pocket and for the pickups and the electronics controls. That shape that they've created needs to get exported to a DXF. And while either of these two methods, for machining purposes, the final product would be done with a spline tool for nice smooth curves, to get it into 3D CAD, if you take a DXF from Partworks, it'll have a bajillion plus data points, and that's a real term too. It'll have too many data points, and it'll crash Pro Desktop, and Inventor will get stuck in the mud. So you can't just take your nice smooth guitar shape and export that to the 3D CAD program because there's too many vertices. So what you do is use the straight line tool and you trace very short line segments, and it's a close enough approximation for the 3D design work that you want to be able to accomplish. So if you're tracing a JPEG, you got two tracing jobs. But you need this version with the straight line segments to take to the 3D CAD program and export it to DXF from there. And you can see each one of these vertical lines represents one of the vertices from the DXF from having created with short line segments. And no, this isn't exactly the same as the other shape that's done with the smooth curves with the spline, but it's close enough for the armrest and tummy cut contour that we want to be able to accomplish. To do the front contour, you're going to make up, like in red here, this work plane at an angle to the rest of the guitar. And you're pretty much going to extrude a triangle. The triangle is this shape right here. And you're going to extrude that either way, whether you place it here and you extrude back, or you place it here and extrude the other way, so that you cut that armrest off. And the result isn't very nice because it's got a pretty severe angle on here, right at this edge. So then you use the fillet tool to round that edge over. And on my shapes, I'm using a pretty big radius. On a Fender Stratocaster, like the vintage style, it's still got a pretty significant flat surface on there, and it has a smaller radius. But I'll go for a smoother radius with this to make the armrest. All this is done by eye. You're making an arbitrary angle for the work plane, you're making an arbitrary size for the triangle to slice it off, and a lot of it's by trial and error. If you change the angle of work plane by even 1/2 of a degree, it can have a dramatic impact on the shape of the body contour in the 3D model. I think that this area is veering very much into art. Because for you engineering folks, I've got numbers for you here. I have 0 numbers. Okay, this is all done by eye for what it looks like and what in terms of having a sense of playing the guitar is going to feel right to hold the finished product. To do the back contour is much the same process. It's either a section of the cylinder or an ellipse that intersects the body at a fairly acute angle. So in this instance, you can see this red work plane right here is maybe 10 or 15 degrees off of vertical. And for this body shape, I chose to draw a section out of an ellipse. Fender Stratocaster, the tummy cut contour though, is pretty much it's a circle, and it's a really big circle. It's a really big circle. And a little bit of it glances off the back edge of the body and takes some material out. And this is the one where a small fraction of a degree makes a huge difference, because you're talking about a very, very large diameter cylinder, and you're going to just have the edge of it skim and barely glance off the edge of the body and take a little bit out. It doesn't take a whole lot of change in work plane angle to make a gigantic difference in how the body contour works. Now once that's done, that'll make a pretty sharp edge as illustrated by that red line. And so to smooth that off in the model, I'll go ahead and do a fillet on that. Again, the Fender Strat doesn't seem to have a very big radius. It's somewhere in the neighborhood of like a 1 or 1.5 inch radius. I use a little bigger one just to make it just a little more comfortable. The trick then is to machine this thing once you've gotten it designed. That's where things get really sticky. You know, if you're doing a 3D CAD course, you're doing Project Lead the Way, Introduction to Engineering Design, you might be hitting some of these topics. But you want to actually machine this thing out, that's a different matter entirely. And this is where it gets kind of problematic. And what I would suggest is go ahead and make up some sketches and plan to extrude in such a way that you isolate the feature by itself. So here, there's like a big L-shaped sketch, and I extruded it and subtracted off the rest of the guitar so that this is the only thing that's here. And the same thing with the rear contour. I made another that's like a big square U, and I extruded it all out so that it wiped out the rest of the guitar body, and all I had was just what I needed from the contour. You can save that as a stereolithography file, and in the Shopbot software, there's another package called Partworks 3D. And you can import that body contour into their program, and they're all along these steps across the top are you're setting up the material, and you're telling it what kind of cutter you're going to use. I don't use a roughing toolpath. I just go straight in for the finished cut with a 1/2 inch ball nose and a very, very small step over. And you got a couple. When you do this, the 1/2 inch ball nose, and then when you save this program, it saves in its own file format called V3D. V3D is one of the file formats that the 2D Partworks program can import. So when you import that in there, that is your V3D file, and it imports it right at the origin. It doesn't matter where you designed it on the guitar body or whatever your project is, it imports it at the origin. So you've got to position it on the guitar body, and again, a lot of this is trial and error by eye. You can do a machining preview and you can see where it skims the body, and maybe it's too far to the right, or maybe you can see where it skims into the scrap and it moves too far to the left or up or down. And so by trial and error, you can get it positioned. From there, once you get it positioned, that puts in the offset from the origin for where the machining actually needs to occur, where it needs to really happen. Now the other thing is, there are a bunch of other extraneous moves. We got toolpath moves here, and we got toolpaths all up here. If you literally cut that file just like that after you brought it into Partworks, inevitably it's going to plane the surface of the guitar where you don't really want to cut it. It's going to cut into it. And you've got the issue, it's got a bunch of tool moves here where there's the scrap. It's a big giant rectangular cutting board. And so there's wood in the way. You can't come down 1 3/4 inches. I actually set the bottom cut not 1 3/4 inches, but like 1.5 inches, because it didn't need to go any more than that. That's the lowest point on the body. But still, it can't take 1.5 inches deep cut and move into that scrap perimeter portion. So that poses a major problem and an obstacle for actually executing this design. Same thing with the tummy cut on the back when the body's flipped over. So you can go and edit. You can go and edit the tool path. It looks like my formatting is messed up here. You can edit the toolpath because it's just a text file. It's just a text file. Editing the toolpath is a very, very repetitive process, and repetitive processes always lend themselves well to some sort of computer intervention. So I've got a program that is hardly user-friendly that I wrote in like 1983 version of QuickBasic that reads the text file in, and it looks for the extraneous moves, and it spits out a duplicate, modified version of the machining code that doesn't have all that stuff in it. So if you didn't have a way to edit this or a program to modify the file, I am bolting my body blanks, you'll see in the picture, along the y-axis of the body, the x-axis of the body. And I could change my mounting so that the bolts would not be anywhere near either the armrest or the tummy cut, and I could actually put in some cuts with a straight bit when it cuts the body perimeter to just cut those sections totally out so it's free and clear so that these moves wouldn't hit anything. You have the downside of machining in air and the lost time. And you could set the z-axis up a little bit higher so that these didn't skim on the surface of the guitar and scuff that up. That would be a way to get around it, so that you could do this, but you have to figure out another way to mount the guitar body. So like, here's one of my mount holes, and there's one of my mount holes. Instead, you can do a mount hole here, and then maybe, there, and then maybe in the corner. And actually, Fender, when they do these bodies, that's how they're set up, is they're set up with a hole down here. So, it would just mean machining another insert in the table, so when you flip it over, you can run the bolt this way when it's face down. That's one way that you could go about doing it. But there's machining preview, and I want all the students to come up with machining preview prior to actually executing. I will say that the 3D contour stuff, there's not a whole lot of students doing that. High school students, with the kind of time frame that we've got, and the expectations and the challenge that this poses. I'm talking about this in 15 minutes. I don't even know how I'm doing on my time because the officials have left the room. You have to listen to every word. So, some body machine tips. Make the start of the vector for the perimeter at the neck pocket. Okay, and then tell PartWorks to start at the starting point rather than optimizing means wherever the router is on the previous toolpath, it'll just take the quickest path and jump over someplace else and whatever's convenient. And you put the starting path here and you tell it to start at this spot. Now when you make a tab for cutting, there's always a little bit of bit deflection when the bit goes into the wood, when it comes back out again. Well, you know you're going to have to sand the heck out of the end grain anyway. So go ahead and put that scarring right there where you're going to sand the heck out of it anyhow, rather than someplace else like on one of the rounded horns or something where you really don't want to alter that shape and run the risk of putting a flat spot or making it smaller. So 2 tabs is what I've got as a minimum by each bolt so that the collet doesn't hit the bolt head. But if you can put 3 or 4 tabs in, it's better. If you've purchased base kits, anybody purchased base kits? They've got 4 tabs on the bodies, and one of the tabs is actually positioned on purpose to serve as a hint as to where to build the edge jacket, the edge jack hole. Okay, I got 3 minutes. There's some examples. I wanted to do a guitar with a different style bridge. I designed everything out in 3D CAD pertaining to the bridge, the nut, the fretboard, and the strings to make absolutely sure that the bridge location would be correct because these saddles do not have a lot of adjustment range like the bridges that we use on the other guitars. It's the only way to know. Each string is a separate loft going from the string nut to its own sketch and work plane off of the bridge saddle. And like I said, modeling this stuff out is the only way to know for sure you've got things in the right place. Once I have a model made up, an assembly made up of the whole guitar with the strings, then I can make an engineering drawing, and I can check and verify. I can find out what the neck pocket angle is, how deep the pocket needs to be, as well as I have dimensions to tell me for sure that the scale length is going to work out, the bridge is in fact in the right place. If it's not, I go back and change where the holes are for the bridge and move the bridge forward and backward until I get it right. Build a test rig out of inexpensive wood to make sure before you cut anything pricey that's like a chunk of 2x6. And I got a neck, and I put 1 fret in it at the 12th fret to make sure it would intonate. Okay, I didn't radius or anything, just put as quick as possible with 2 strings to make sure it'll work. To design the neck, you got to do the headstock thing and plan and figure that out. The neck itself, there's a loft. It's these C-shaped sketches, one for the nut area and one by the heel. And you're subtracting that out, and that gets you started. To do the heel volute, I'll take another sketch that has a right angle to it. So the 2 sketches are at right angles. The one with the C-shape cut out for the heels here, and the other one is over the heel. It's an empty rectangle, just a plain rectangle. And when you loft it, it sweeps like this. Depending where you put the rectangle and how big you make it, or how small you make it, affects how the volute is contoured. Very much trial and error. And then some fillets, kind of clean up some of the edges and smooth it out. And the same thing at the heel. I got a giant sketch here, and I got the same sketch I used before on my main neck run loft, and I did a loft, and what happens is this little rectangular shape fans out, so it doesn't do anything to harm the headstock, but it fans out. Even if it did, it didn't matter, because we're not using that, but it fans out and gives me the kind of contour that I want. I'm not 100% happy with the way the nut volutes work, but that's how I've been doing the neck design. This opens up the opportunity to be able to do any kind of neck profile that you want. So if you look at the history of Fender guitars, they've got like 3 or 4 major neck contour shapes that they use. And you can go ahead and make up whatever contour you want. So rather than what's in the kit, which is fairly C-shaped and rounded, I've got a V-shaped neck going on here, and it literally comes rather pointy. So I put a fillet on it to soften that edge. And then there's a neck that's all done. Same deal. Make up a work plane with some sketches and amputate the ends of the neck. And it's the same deal to take the tool pass, move out the extraneous moves. Is my time up?
Yep.
Okay. And then we've got some other tips about getting all this wood out of the way. Get rid of that wood, get rid of that wood so that the cutter doesn't hit it. Start your vectors where the, that was important, it's too bad I ran out of time. We're all done, here's some expensive wood. There's the guitar all finished. Here's some other things I did some body contours on.
Cool.
And that's it. All right, sorry I didn't have time to get through all of it.